Dissecting the atom. Understanding what's in an atom. Special note. There is a study guide accompanying this film strip which reviews the concepts and provides problems with worked-out solutions for you to follow. Now see if you can accept the true challenge of understanding the terms and concepts involved in what's in an atom. Some problems will be presented to you. Try to follow them. Then try to work out the next several problems on your own and follow the worked-out answers. Silicon is an element which has three naturally occurring isotopes. The isotopic symbol for one of the isotopes is 14Si29. What would you say is the atomic number of silicon? If you recall, the number in the lower left-hand corner of the isotopic symbol is, in fact, the atomic number. Thus, the atomic number of silicon is 14. What, then, is the mass number of this isotope? The mass number, if you recall, is the number written in the upper right-hand corner of the isotopic symbol. Therefore, the mass number of this isotope is 29. All right, now, how many protons are present in silicon? This requires your recollection that the number of protons is equal to the atomic number. Therefore, there are 14 protons in silicon. How many neutrons are present? Well, the sum of the protons and neutrons is equal to the mass number. Since you calculated that the mass number is 29, you know that the sum of protons and neutrons is 29. You also found the number of protons to be 14. To calculate the number of neutrons, you can just take the difference between the sum of the protons and neutrons and the protons alone, giving you 15 neutrons. Okay, now how many electrons must there be outside the nucleus of this silicon isotope? Remembering that atoms are neutral, you should realize that there must be equal amounts of positive and negative charge, and that, therefore, the number of electrons must be equal to the number of protons. In other words, since the charge due to the protons is plus 14, by having 14 electrons, you get a charge of minus 14. This gives you an overall charge for the neutral atom of 0. Another isotope of silicon has 14 neutrons. How many protons must it have? No calculation is really needed here. Remember, isotopes of an element always have the same atomic number because it is the atomic number or number of protons which identifies that element. Thus, the number of protons is, once again, 14. All right, try this one. Aluminum has a naturally occurring isotope containing 13 protons and 14 neutrons. Calculate its atomic number. The atomic number is equal to the number of protons, so 13 is the atomic number. What is the mass number of this isotope? The mass number is the total number of protons and neutrons, or 27. How many electrons would be present outside the nucleus? Since the atom is neutral, 13 protons require an equal number of electrons, or 13 electrons. Now see if you can write the complete isotopic symbol for this isotope of aluminum. The number in the lower left-hand corner is the atomic number, or 13, while the number in the upper right-hand corner is the mass number, or 27. Therefore, your answer should read 13Al27. The next several problems are meant to be worked out by you before you look at the answers. For each example, take down all the information given, shut off the projector, and after working them out, watch the worked-out solutions. The element iron has 4 naturally occurring isotopes. One of them has the isotopic symbol 26Fe56. See if you can calculate the following. A, the atomic number. B, the mass number. C, the number of protons. D, the number of neutrons. E, the number of electrons. Your answer to A, the atomic number, is the number in the lower left-hand corner of the isotopic symbol, or 26. Your answer to B, the mass number, is the number in the upper right-hand corner, or 56. How many protons? Well, the atomic number is equal to the number of protons, so there are 26 protons. In answer to D, the number of protons and neutrons are 56, the mass number. Since there are 26 protons, the difference between these, or 30, is the number of neutrons. Finally, since the atom is neutral, the number of electrons is the same as the number of protons, so there are also 26 electrons. Suppose now you are given one of 7 naturally occurring isotopes of barium, which contains 56 protons and has a mass number of 138. Try to calculate A, the atomic number, B, the number of neutrons, C, the number of electrons, and D, write the complete isotopic symbol for the element. Remember to shut off the projector. In answer to A, the number of protons is the atomic number, so the atomic number is 56. The number of neutrons, asked in B, can be found by subtracting the number of protons from the total number of protons plus neutrons, or, in other words, by subtracting the atomic number from the mass number. 138 minus 56 gives you 82 neutrons. In C, the number of electrons is the same as the number of protons, or 56. Finally, the complete isotopic symbol would be 56Ba 138. All right, how about this one? One of the 8 naturally occurring isotopes of lead has 82 protons and 126 neutrons. Write the complete isotopic symbol for this element. The isotopic symbol is composed of the atomic number, the symbol for the element, and the mass number. The atomic number is the number of protons, or 82. The mass number is the sum of the protons plus neutrons. 82 plus 126, or 208. Therefore, the complete isotopic symbol is 82Pb208. Here is a different type of question for you. Which of the following are isotopes? 19K39, 19K40, and 18AR40. Hopefully you answered 19K39 and 19K40. Why is this correct? What makes them isotopes? They have the same atomic number, 19. They each have 19 protons and are, therefore, the same element. It is their number of neutrons which differ. 19K39 has 20 neutrons, while 19K40 has 21 neutrons. Argon, of course, could not have been an isotope, since it is a different element. These problems were designed just to start you thinking about some of the terms and concepts you have learned. Practice, as usual, is the best method in dealing with them. You will find more problems to challenge you in the study guide accompanying this film strip. You are now gathering tools to use in understanding why atoms do attach to each other, forming chemical bonds.